This sketch shows the telescopic shock absorber. So if you see any modern bikes, okay, say for example, if you take Pulsar, you can clearly see if this is the handle portion. Okay, so there will be a beam like this. You can see the telescopic shock absorber. Okay, so this part will be connected to the wheel. So this telescopic shock absorber, you can just note in the modern bikes. Once again, okay. So this sketch shows the telescopic shock absorber. So A is the inner cylinder. So this is the inner cylinder, and B, whatever you can see, this portion is the outer cylinder. So A is the inner and B is the outer cylinder. So 1 and 2 are the two-way valves. It will allow the oil to flow in upward and downward direction. So these are the valves. Okay. So 3 is the piston rod. So this is the piston rod. You can see here 3. This is the piston rod. Okay. 4 is a gland. So this gland stops the leakage of oil in your bike. If there is damage of the gland takes place, then you can see the oil leaks. And in the handle, there will be a small lever which indicates okay the oil level of the disc brake. So that starts coming down if this gland is weak. Okay. So this is the gland which prevents the leakage of oil. 5. This part we call it as the head, complete sealing mechanism. This is the head, and this is the eye connected to the frame. Okay, so this is 6 is connected to the axle, which in turn will be connected to the wheel. 7 will be a fixed one, which will be connected to the frame. So these are the different components of a telescopic shock absorber. Okay, its working is very simple. Whenever, as I told you, the important components are these two-way valves here. Okay, so whenever there is a hump, when your bike, say for example, I'll take the example of a bike, when it passes through a hump, so this the eye connected to the axle, which in turn wheel will be connected. So this moves up. Okay, so when this moves up, what happens? The pressure will be exerted so that the oil, so cylinder 1 and cylinder 2 are completely filled with oil. So the excess oil will start moving down. You can see here. So this A, whatever you can see, okay, this part moves up because of the pressure exerted, so that the oil moves up, and this whatever second cylinder is there, the oil level rises here. Okay, so once the hump is crossed, what happens? Okay, the axle comes back to its position, so that here a vacuum will be created, so this oil will be sucked back. Okay, so this is the mechanism. The oil moves inside and out of the outer cylinder in order to absorb the shocks. Okay, here the two-way valves will not promote the oil to move immediately. They will have some resistance for the movement of oil. That resistance itself will act as the damper. So that is why you don't feel any vibrations or oscillations when the vehicle is moving. Okay, so this is regarding the working of a telescopic shock absorber. So in the video also we have seen. So this video yesterday we have seen in that telescopic shock absorber was clearly mentioned. 1 second, please. Once again, just okay, this is the example of a telescopic. Two cylinders will be there. So these are two-way valves. So this is what the same concept is discussed here. Okay. So next, types of suspension system. Make a note of it. There are two types majorly, front and rear. Okay, in front again we have independent, non-independent, and in the rear we have independent and non-independent. So this is a classification of suspension system. Okay. So next, as we discussed, what do you mean by independent suspension? Each will have a separate mechanism. They are not interlinked. So what are these advantages of independent, or it is also called as rigid axle suspension? So in case of independent, that is each will have a independent suspension mechanism. In such cases, you can use light springs comparatively. Okay. Soft springs with higher flexibility you can use. So the rolling effect, whatever in the very first slides we saw, that rolling effect will be reduced. Okay, improved steering precision. Okay, because you are not linking two wheels. Okay, they are all independent. Okay, so that the steering precision will be better. Okay, it will be easy to locate the springs to understeer condition. We have discussed understeering and oversteering. So setting of this understeering and oversteering will be easy. Steering geometry will not be altered when the spring is deflected many times. Okay, so these are some of the advantages. We will just make a note of it. Okay, is it done? Yes, is it done?
Sir. Yes, sir.
So the next advantage is the vehicle chassis can be placed relatively lower. Okay, engine can be moved forward, increasing the space. Okay, leg space inside the vehicle as the engine can be mounted at the frontmost position. Okay, so these are some of the advantages. Limitations are high initial cost. For each wheel, you have to plan for an independent mechanism. So initial cost will be more. Maintenance, definitely it will be more. If one mechanism is handling two wheels, then two mechanisms for the entire car would be enough. Here, what happens for each wheel, you have to plan for individual mechanism. Four, almost number of components will be more, so that maintenance will be more and cost will also be more. Okay, misalignment of steering geometry with wear and tear of components is observed as compared to dependent. Okay, in the event of rolling of the body, the wheels camber resulting in decreasing the cornering. During cornering, rolling effect will be increased. Okay, you have to plan for a rigid chassis as it has to accommodate four different types of suspensions. Okay, force due to unbalanced wheels are more pronounced. The balancing of wheels along with alignment will be done. Sometimes you can see the wobbling of vehicles. Okay, so you don't find the stability of the vehicle. At such cases, you take it for service and leave it for balancing of wheels. Okay, in such unbalanced wheels, you can drive to some extent, but dependent steering system is, if suspension system is there. Okay, the unbalanced effect, whatever you feel, will be lesser. Whereas in independent, the effect that you feel will be more. So these are some of the advantages and limitations. So please make a note so that we will start discussing different types of independent suspension systems. Okay. So next, different types of front wheel independent suspension systems. So as per our syllabus, as we saw earlier, we have to study 5 types: wishbone type or parallel link type, MacPherson strut type, vertical guide type, trailing link type, and swinging half axle type. So 5 types are there. So we will describe one after the other. They are very simple. Okay. So the first type is the wishbone type suspension. You just take down the sketch. Okay. You can take down this rough sketch. In exam, if you are not able to draw this, a simple one I have searched for. So this is how actually the wishbone suspension looks. Okay. Okay, I hope it is done. So this whatever wishbone type independent system is there, it is the most common type of independent system that is used in most of the four wheelers. Okay. You can see the main components are the spring. Okay. This spring you can clearly see here. Okay. Inside the spring there will be a shock absorber or a damper. Okay. To avoid, say for example, if there is any road bump, when the wheel moves up and down, what happens? The shock will be absorbed, but spring keeps oscillating for a period of time, then it stables. In order to avoid these oscillations, a damper will be used, wherein the excess energy in the spring will be absorbed and it will be slowly released. Okay. So this is the spring and the damper. Okay, the upper and lower wishbone arms. So this is the upper wishbone arm and this is the lower wishbone arm. Okay, so the upper and lower wishbone arms are pivoted, that is firmly attached to the frame. You can see this is the frame or chassis of the vehicle. So one end is firmly attached to the frame, other end is connected to the kingpin. Okay, to which the disc of the braking mechanism and the wheel are attached. So this is regarding the construction of the wishbone type suspension system. Okay. So once again, I'll repeat, there will be a spring. Within the spring, there will be a damper. You can see, okay, the upper wishbone arm and lower wishbone arm. One end will be pivoted to the frame or chassis. You can see it is pivoted firmly. So the other end will be connected to the kingpin, which in turn the braking system and the wheel will be connected. So with this sketch, you can clearly see the same mechanism here. Okay, so this is the upper and the lower wishbone arm. One end with this end will be connected to the chassis. You can see the spring here. Okay, and this is the damper. The red color, whatever you can see, that is the damper. Here, this mechanism will be connected to the wheel hub, that is kingpin. So the kingpin in turn will be connected to the wheel. So this is the construction of wishbone type of suspension system. Okay. The vehicle weight is transmitted from the body and the cross member. Cross member is nothing but the chassis, okay, or axle, whatever is there. Okay, so directly it will be transmitted to this, so that there will be always some small tension in the spring. So it will be little bit compressed. The entire body weight falls on this. Okay, the shock absorber is placed inside the coil spring and it is attached to the cross member. You can see in this sketch, you can clearly see how the shock absorber is placed. So one end is completely fixed in the lower, the other end is directly connected to the axle. So the axle will be there. Okay, so the axle or frame, the other end will be directly connected, so that the entire body load, entire body load will be taken up by this mechanism. Okay. So the main advantage of this type of suspension is it can take up different types of not only the disturbances in the road, it can take place vibrations that is caused during a sudden acceleration, sudden braking, that is pitching action we were discussing about in the last class. Okay, when there is a sudden pitching, that is when you apply a brake, the vehicle tends to bend down. The front part bends down and the rear part lifts up. So that is called as pitching. Such actions it can easily absorb. And when you are driving it through a curve, the rolling action, whatever will be their side forces or cornering forces, we call it as, that can also be taken easily. Okay, so usually this upper arm is kept shorter than that of the lower arm. This is the lower arm, you can see the length, and the upper arm is usually kept, okay, shorter. So to keep the wheel track constant and to reduce the wear and tear of the tires. Okay, so if both are at the same length, okay, and the track will not be constant, so that one end gets worn out faster. In order to reduce the tire wear and tear, okay, so always the upper arm is kept shorter and the lower arm is made large. So this is about the wishbone type system. If you are not able to draw this sketch, you can draw this simple sketch. This is the upper wishbone arm, lower wishbone arm. Okay, you can show a damper here and a spring. One end is connected to the chassis. Okay, other end is connected to the kingpin. This is the kingpin, which in turn is connected to the wheel of the system. Okay, so this is the first type of independent system. You can just go through this video. Clearly, here it is explained. I think you are getting an idea just by seeing the first part. You can clearly get an idea. Just he has given in detail about this suspension mechanisms. One second, please. Okay, so this part of the sketch you can clearly see how the this wishbone. Okay, so this is the upper arm, it is shorter, lower arm, this is the kingpin. So this is the cross member or axle or the part of chassis. One end is pivoted, other end is connected here. You can see there is a spring inside, that yellow color is the damper mechanism. Okay. Now next, history and all we will just. Okay, what are the advantages of wishbone mechanism? Easy to control the wheel motion. First thing, easy to tune camber variation. So whatever independent system advantages we have discussed, whatever I have summarized, same holds good here. See, there will be a wheel hub. This is the hub. Lower link, which is a longer one. Upper link is a shorter one. Next, this is the frame. You can see one end is completely rigidly pivoted to frame. This is the shock absorber with a spring mechanism. Coming to working, see when there is a bump, how it works. You can clearly see. Okay, this damper slowly releases so that this chassis member is not feeling any vibrations. It is not getting vibrated or getting moved. So that only wheel will be acting like this. The inner passenger will have a complete comfort. So this is how a double wishbone arm mechanism works. So disadvantages I have summarized in the beginning itself. Overall high cost, high maintenance, more space is required. These are all the common disadvantages, and it is bulky, more number of parts are there. Okay. I think this mechanism you understood clearly. The second type is MacPherson strut type suspension. Okay, please take down the sketch. I'll give you 2 minutes time. Take down the sketch. Okay. So again, if you understand the first mechanism, it will be easy for you. Okay. So here a strut containing shock absorber. This is a strut. Yeah, or in simple words, I can call it as a rod containing the shock absorber. So this shock absorber mechanism and the spring, yeah, is the stub axle on which the wheel is mounted. So it is directly mounted onto this stub axle. Okay. So the lower wish bone, whatever you can see here, the lower bone, okay, it is directly hinged to the cross member. Cross member means your chassis or the axle. Okay. So it helps in positioning the wheel properly. It holds rigidly, and any acceleration, deceleration, braking forces will be taken care by this. Okay. So again, the mechanism of working will be same. When the wheel moves up and down, this whatever strut member is there, through that the load will be shifted to the spring mechanism, so that this also moves up and down, so that the persons who occupy the car will be of maximum comfort. Compared to the first mechanism, this is simpler in construction. It will give maximum room in the engine compartment. Okay, because that was a larger mechanism, so it would occupy more space. Space is one of the most important concern. Okay, this system provides increased road safety, and this was used in Maruti 800cc cars. What the Maruti 800 first MacPherson prototype was popularly used in Maruti 800 cars.